result in a different sample proportion, even if we are getting the same sample size. So this implies that your sample proportion is going to be a random variable. And any random variable has a distribution. The distribution has a mean and a standard deviation. When we are talking about P, so the mean is going to be pi, and the standard deviation is going to be the square root of pi, 1 minus pi over n, and we can prove this. Okay, now the point is, I would like to get probabilities related to the sample proportion. And in statistics, we would like to use the normal distribution to obtain these probabilities. How are we going to obtain these probabilities for something that's not even quantitative or so it's not quantitative. So when you're talking about proportions, so we're talking about a qualitative variable. And the normal distribution is only dealing with continuous variables, so quantitative and continuous. So our trick is to manipulate your data in order to reach something that's similar to X bar. And if you are able to reach something like this, so you can apply your central limit theory. So what's our trick here? We say that, for example, if I would like to calculate the proportion of smokers in a sample, for example, of 5, then, for example, if I have 3 smokers, yes, 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 no, no, then this means our proportion for smokers is going to be 3 over 5. If you give you the value 1 to your success and the value 0 to your failure, then X bar is going to be 3 over 5, same value as the proportion. So this means you are able now to treat P like you treat X bar. And what applies to X bar can be applied to P. So what's the thing that we would like to apply to P? We would like to apply the central limit theory. So if you have a sample of size n, a sample of size 30 or more, then since your sample is not coming from a normal distribution, but you have a large sample size, then P, your sample proportion, is also normal, is approximately normal, with mean equals to pi, the original population proportion, and the standard deviation, which is square root of pi 1 minus pi over n. Using some simple tricks, okay, we can also find the probability for the number of successes based on what we've reached in this part. Number of successes can be approximated using the normal distribution, and we call this approximation, it's the normal approximation to binomial. How did we reach this? So, for example, I can find the probability of P, the proportion, okay, bigger than a certain value. How do we standardize for P? What's our z-score? So our z-score, it is P minus pi, square root of pi 1 minus pi over n. We can manipulate this, so I can write square root of n P minus pi divided by pi 1 minus pi. Okay, if you multiply the numerator by root n and the denominator by root n, so what you will get is n p minus n pi, okay, minus square root of n pi 1 minus pi. So this will give you the z-score for the number of successes, because we know that NP is going to be the number of successes, okay? NP is the number of successes. And the way to standardize this is going to be by subtracting n pi and dividing by the square root of n pi 1 minus pi. And this is how we use the normal approximation to the binomial distribution. Okay? When we solve, you will understand more about this part of the lecture. Suppose that y has a binomial distribution with n equals to 25 and p equals to 0.4. Find the exact probabilities that y is equal to 8. So we have a binomial distribution, so we can easily find the probability for y equals to 8. So we use the form of the binomial distribution. And compare this to the corresponding values found by the normal approximation. So the exact probability is going to be y equals to 8, and we can calculate this. And from the tables, we can find probability y less than or equal to 8. We have binomial tables. Instead of calculating all these probabilities from the binomial tables in your book, you will find the probability of y less than or equal to 8 is equal to 0.274. So how are we going to find the approximation for y equals to 8? We know that probability y equals to 8. If we're going to deal with this assuming that y is continuous, so the probability is going to be 0. But in this case, I'm going to have a very simple trick. So I'm going to use something called a continuity correction. I know that I'm talking about a discrete random variable. So if I'm going to use a continuous variable to approximate a discrete one, I have to use this continuity correction. What's the continuity correction? So this means I would like to find the probability of y equals to 8. So what I'm going to do is I'm going to subtract 0.5 and add 0.5 to this 8. So, and then you can use your normal distribution. So y is going to be 8 minus 0.5, 7.5, and then here you have 8.5. This is not the end of the question. Of course, you need to standardize this y. Y here is the number of successes. So this means you have to use the corresponding z-score. What's the corresponding z-score? So it's going to be 7.5 minus np. np or npi. So what's pi is what they gave to you in the population. So they gave you that pi or p is equal to 0.4 and n is equal to 25. So n is 25, and they asked already for using this approximation. I know that n is bigger than less than 25, less than 30, but they ask you to use the approximation when n is 25. So it's going to be n times p, so it's 25 times 0.4 divided by np, n which is 25 times 0.4 times 0.6. This is how we approximate this part. So it's going to be 0.25, 0.4 times 0.6 times 25. It's going to be 6. So we talk about root 6. Okay? Same z, it's going to be 8.5 minus the mean, which is going to be 10 divided by root 6, and you get this probability from the normal table. Okay, so these are the upper and the lower limit for the probabilities that we are looking for. Now the question is asking for find probability y. So back to the question, y less than or equal to 8. Okay, less than or equal to 8. So let me teach you one thing. So in order to use this approximation with y equals to 8, so what I'm going to do is I'm going to draw the number line. So here is 8. If it should be y less than or equal to 8, but let me see how I solved it here. So y less than 8. Y less than 8 means 8 is not included. So if 8 is not included, so this means I'm not going to include 8. So this means I have to find the probability y less than 7.5. So I have to do this continuity correction. If y is included, if 8 is included, so this means in order to have 8 in my probability, so it's going to be 8.5. So in this case, the probability is going to be, this one is going to be probability y less than or equal to 8.5. So therefore, this is missing less than or equal. Okay, so y is less than 8.5. And then you can use the normal table with your z-score to find y less than or equal to 8. So you have to think whether the value is included or not included, whether it is bigger or smaller. Okay, so we can just try to have a summary here for the continuity correction. Okay, so I have here, okay, for example, if x or y is between 1 and 2, 1 and 2 are included. So this means 1 and 2. So I would like 1 to be included. So this means I have to start from here, because if I start from here, 1 is not going to be included. So this means I have to have 1 minus 0.5. And then 2 is included. So if I subtract half, it's going to be less than 2. So 2 is not going to be included. So in this case, 2 plus 0.5. Okay,